Let's talk about lights. We have discovered different materials, some like the basic material that doesn't react to light and it always appears the color that it is supposed to be. In opposition to that, we discovered the mesh standard material that react to light and the color is impacted by the light and the distance with the light and the position. As it applies to our real physics world, lights are illuminating the objects and create nice effects. In 3D development, the same concept applies and you can create a light that simulates the sun, a lamp or any other light sources. When we run the starter project, we can see a black plane. It's because it has mesh standard material and we have no light sources. So everything is black. Let's use this scene to discover the different types available with Three.js and React 3 Fiber. The simplest one is the ambient light. It illuminates all objects regardless of their position and their distance to the light source. It only reacts to the intensity and the color of it. Let's add an ambient light. It's from Three.js, so camel case. Let's set the intensity to 0.5. The default value is 1. And let's see what we have just by doing it. We add it like any other object inside our canvas. We can now see the color of our object. The plane below is white but appears a bit gray because of the low intensity of the light. And the cube is red. We can change the color of the light with the color property. It takes 3 colors, so it works the same than the standard material or any other color in Three.js. Let's say royal blue. Now you can see that our objects appear differently. The floor that is white appears blue, and the red is mixed to the blue, so it appears very dark and almost black. Ambient light is good to be used as a foundation to define how bright or dark the scene will look like, but you need to add other type of light to make it not that flat. Let's remove the color prop of our ambient light and maybe reduce a bit the intensity. And let's add another type of light, the directional light. It illuminates all the objects in the scene from a specific direction. Think of it maybe as the sun, because it's so big it illuminates everything, but the position of the scene impacts the way things will look. As other lights, it has an intensity prop. Let's put it 0.5. And it takes an additional prop, which is the position. Let's define it to 3, 3, 3. And it also have a target to say where is the light looking at, but the default value is 0. So it just impacts the direction. You can always use 0. Just by adding this directional light, the scene looks way more 3D. Let's add multiple directional light with different colors to see how it interacts with our objects. Let's switch this one to red. Let's create another green one. We can set its position to 0, 3 and -3. And another blue one in -3, 3 and 3. To better see how it impacts the color of our cube, we can set it to white. Now you can see that the floor has a mix of those colors and we can see where are the lights. The blue ones appear like it's on the left and close to us. The red one looks like it is on the right and close to us, while the green light is behind. Now let's discover another type of light, the point light. It's like a light bulb. We can remove our existing lights and add a point light with a position on top of 10 and an intensity of 0.5. It's a light coming from above, but there is a prop that will help us make it more smooth. Without the distance prop, all items are lightened equally. But if we set the distance to 3 and position it closer to the cube at 1, 1, 1, it's like we have a small invisible light, but we can imagine we have a light bulb at that position. We can also use the decay prop to define how the intensity of the light diminishes based on the distance. But finding the right values can become tricky when you play with your code and visualize it and fine-tune. It's time-consuming. But in the debug lesson, we discovered tools that can help us find the correct value. Let's add a helper to our light. Let's create a reference to it. Const ref is equal to useRef. Don't forget to import it. Attach it to your light. Declare a helper. It will be equal to useHelper of 3.pointLightHelper but the first parameter is the reference, sorry. So reference, then the type of helper. For the point light helper, it's the sphere size, or the size of the helper. Let's say it's 0.5, and let's set the color to red. Now we need to import 3. But we will get this error. It's because we are using a hook from React Refiber outside the canvas component. So we need to wrap our light into a sub-component and to use our hooks from there. Let's create a light component. Const lights is equal to a function. We will return our point light. And here we will render the lights instead. We paste it here. And now our reference and our helper, they will be in the lights component. Now, thanks to the helper, we can see where our light is positioned. Let's use Leva to adjust the parameter and the position of the light. The different parameters we will need are the color of the light, the distance, the decay, and the intensity. We will use controls from Leva. Let's set the color to red by default, the distance to 3, the decay to 2, and the intensity to 0.5. Now, instead of using those values, we will be using the one from the control. Intensity, distance, decay, and color. Now we can adjust the color of the light. It will be impacted in real time. Let's say I want something like a purple light, but it's too dark. So let's increase the intensity, maybe increase the distance so it appears more. And that way we can fine-tune our parameters. Let's jump to the next type of light, the hemisphere light. Let's remove everything we've done here. We'll be using a hemisphere light. Instead of just having one color, it has the color property as the other, which is the sky color. So let's use deep sky blue. And the other property is the ground color. So it simulates like the light of the sky with the lights coming from the ground surface. So for the ground color, let's use something brown, like sandy brown. It also has an intensity prop, but we can keep the default value. Now what we see is we have the floor and the top of the cube that appear of the color of the sky, but the side of the cube, they have this nice mix from the sky and the ground color. Let's see a last type of light for this lesson, the spotlight. It's a light that gets emitted from a single point in one direction along a cone that increases in the size further from the light it gets. So you really think of it like a spotlight you have. But for this component, instead of using the one directly from Three.js, we can use the abstraction made by React 3 Dry. We can find the definition in the GitHub repository, inside the staging section, Spotlight, and we have the different options it has. When you see pictures on the different section, it means it comes with an example, one or multiple ones. That way it helps you visualize what it is and how to use the component. So let's declare ours. And because it's difficult to configure it manually, let's use a helper and controls. Helper is equal to use helper of the reference. So first we need to create our reference with useRef, attach it to a spotlight from Dry. Ref is equal to ref. We remove the other props. And let's finish configuring our helper. So 3.spotlight helper. And now it's the color of the helper. So let's use red. Then let's use Leva for the different properties of spotlight. So we'll have the color, the distance, the attenuation, the angle, and angle power is equal to use controls. And let's define the different values. For the distance, let's put 6, attenuation 2.2, angle 1, and angle power 1. Now let's attach it to the spotlight. So color is equal to color, distance is equal to distance, attenuation is equal to attenuation, angle same, and angle power same. Instead of doing all of this, you can just get an object and destructurate it into the spotlight. But it's more easy to discover all the props together doing this. Let's save, Prettier on my configuration does its job and put the things on the line. Don't forget to import 3 if it was removed from the previous save without it. And we can play with our spotlight. So we can play with the distance. You can see it's more intense and now it gets blurry on the side. The attenuation factor. So you can see, I don't know if it's very visible, but look on the bottom of the cube, it gets more intense. We can change the angle, make it very thin or very wide, and the power of the angle. When we talk about light, it's important to speak about materials, because if the lighting is one part of the equation, the correct use of materials and the different props they have, the different parameters you can play with, it will impact the rendering of the objects. Let's change the roughness and metalness of our cube. We'll set the roughness to 1, so it will reflect nothing, and metalness to 0. While on the floor, we'll do the opposite. We'll put a roughness very low, so it should reflect more light, and a metalness with a high value, so it will look metallic. See that without touching the light, the floor appears completely different. It's very bright and reflecting the spotlight. We don't see the spotlight, but we see its reflection. And if you can get the visual effect you want with a specific material, you can try different material. For example, the mesh physical material. It's an extension of the mesh standard material with additional props. So think of it, it is more consuming resources. So only use it if mesh standard material is not enough for what you're trying to render. Let's change our ground, our plain ground, with a mesh physical material. We'll keep the color to white, but we will use the different props we have. So the clear coat with 0.5 and the reflectivity to 0.8. And as before with the mesh standard material, the plane is reflective. We can see the spotlight, but it's way more sharp and precise.